Hey guys, here is the question number 12, and in this questions we'll talk about parallel plate capacitor. And in every exam, I think, and in JAM, NET, TF, GATE, every exam nowadays, examiner asks questions from this parallel plate capacitor. So this type of questions is very important for the competitive exam. So let's see what we have to solve in this problem. A parallel plate capacitor with spacing D and area of cross section A is connected to a source of voltage V. If the plate are pulled apart quasi-statically to a spacing of 2D, then which of the following statements are correct? So this is a MSQ questions where more than one options could be correct. So in this case, we have to check each option. So there are 4 options and we have to check these 4 options. Okay. So before solve this problem, just let me write two situation. Situation 1, or let's say final case and initial case. So here I'm writing left side, I'm writing a initial case. Initial case. And on the right side, I'm writing final case. Okay, initial case and final case. So in cases, what has been written in the questions that we have a parallel plate capacitor. So let's say this is a parallel plate capacitor, and each plate have a cross section area A, and initially the spacing between them was D. So the spacing between them is D. Cross section area is A. Now this parallel plate capacitor was connected with the battery voltage source, and the voltage of the source is V. Okay, voltage of the source is V. So what will going to happen, as soon as we'll connect this capacitor with this voltage source, the battery will, this capacitor will get charged, and charge will start storing on the capacitor. So after some times, this battery will get fully charged. Sorry, this capacitor will get fully charged. And then what has been said in this question that now after charging this capacitor full charged, if we want to increase this separation D to 2D, so now in final stage, the separations between two parallel plate capacitor or parallel plate has been increased from D to 2D. So now the separations is 2D. Cross sections remain same A, and still the capacitor is connected with the same source. So without disconnecting this capacitor from the source, what has been done, only the plate separations has been increased from D to 2D. So since the battery is connected with the voltage source, so still there will be some charge on the capacitor. So these are the two situations. So in these situations, we have to remember one thing, that after getting the full charge of battery in the first case, the voltage across this capacitor, sorry, after getting the full charge of the capacitor, the voltage across the capacitor will be V. And then without disconnect this capacitor, if we increase distance or if we decrease the distance between two plates, the voltage across the capacitor will always remain same. There can be other situations also, like after charging this capacitor, if we disconnect this capacitor from the circuit, and then if we increase the distance between these two plates, in that case charge on the capacitor will remain same, but the voltage will changed. But in these questions, we are not disconnect this capacitor from the battery. So still capacitor battery is connected with the capacitor, and we have increased the space between these two parallel plate capacitor D to 2D. So in this situation, in this case, first case and initial case and final case, both the situations, the voltage across the capacitor will always remain same, and that voltage will be V. Okay, that voltage will be V. So let me few other parameter related to the capacitor, and let's see in initial case and final case how they will going to change. So in first case, if we want to write the capacitance of the capacitor, so C initial, what will be that capacitance? We all know parallel plate capacitor. If a parallel plate capacitor have cross section area A and the plate separation is D, and the medium between two parallel plate is air, then the capacitance is written A epsilon naught divided by T. So this is the initial capacitance of the capacitor, and then voltage across this capacitor after getting the full charge, the voltage across the capacitor will be V. So the charge that will store on this capacitor, that I am writing initial charge, the charge on the capacitor in initial case when the separations between them is two plates is D. At that time, the charge on the capacitor will be C initial into V. Now C initial is A epsilon naught divided by D into V. So that amount of charge will store in the capacitor when the separations between the plate is D and the capacitor is fully charged. And what will be the energy in first case? U initial energy that will be stored in the capacitor, that we can write half C initial into V square. C initial into V square. So what is C initial here? And A epsilon naught by D. So if we put it here, what will get? A epsilon naught V square divided by 2D. Okay, 2D. Now take a look. When we increase the separation of this two plate from D to 2D, then how this parameter will going to change? Are they remain same or they will be different? So here the main parameter that will remain same, that is the voltage across the capacitor. Both the situations it will remain V. Here it was V. In this case it will also be V. Both the situations voltage across the capacitor will be. Why? Because it is still connected to the source. Okay. Now the next thing is, what will be then capacitance of this capacitor at the final case when the space between these two plates is D. So C final, it will be A epsilon naught divided by 2D. This is the final capacitance, and then voltage will remain same, but now capacitance is changed. So the charge that will be stored when the space between these two plates is D, that will also get changed. Now what will be that charge? Charge will be C final into V. So it will be A epsilon naught V square divided by 2D. So this will be the final charge on the capacitor, and the final energy that will be stored in the capacitor when the spacing between them is D, that will be half C final into V square. So if we put the value of C final here, what we'll get? We'll get A epsilon naught V square divided by 4D. Divided by 4D. So these are the main parameter. They will going to change when the spacing between them, spacing between our two parallel plate will increase from D to 2D. Okay, so now if I want to calculate that how much charge is reduced when the capacitor is the plate separations is increased from D to 2D. You can see here initial charge was A epsilon naught by K epsilon naught V divided by D. Final charge A epsilon naught, oh no, this will not be square, this is V. A epsilon naught V divided by 2D. So here you can see the final charge is less than the initial charge. So what will be the charge? How much charge will reduce in the capacitor? So the charge on the capacitor reduces by dq is equals to q initial minus q final. Q initial was A epsilon naught V divided by D. Q final is A epsilon naught B divided by 2D. So the amount of charge that reduced on the capacitor will be A epsilon naught V divided by 2D. So this amount of charge reduce when the plate separations of the capacitor is increased D to 2D. The second thing I want to calculate here, the energy of the capacitor, how much energy of the capacitor is reduced in this case. Again, you can see here, this is the final energy, this is the final energy, this is the initial energy, and here you can see the final energy is less than initial energy. So in this case, energy on the capacitor will also reduce. So the energy of the capacitor reduces by delta U is equals to U initial minus U final. What was U initial? U initial was A epsilon naught V square by 2D. A epsilon naught V square divided by 2D, and final energy A epsilon naught V square divided by 4D. So the amount of energy that reduce the capacitor will be A epsilon naught V square divided by 4D. V square divided by 4D, and that is the option number D. Well, in option D, it is written the energy of the capacitor is reduced by 1 by 4 epsilon naught A V square divided by D, and we exactly getting the same answer here. So that's mean option D is correct. Option D is correct. Okay. Now what are the other options? Other options, in option C it is written that the force between the plate at spacing 2D is this. That means we have to calculate what will be the force between the plate between these two plates. Why there will be force? Because one plate is carrying positive charge, another plate carrying negative charge, and positive charge, negative charge, they attract each other. So because of that there will be force. So now we have to calculate what will be the force on that between these two plates when the separations between them is D. Separations between D. So for that I'm assuming that a situation where the plate separations is x, where the plate separations is x. This separation is x. Battery will still remain connected with this capacitor. So here you can see, after getting the full charge of the capacitor, so if we change the spacing between them, the voltage across the capacitor will remain same, but the charge will change. Why this charge will change? Because as we change the separation, the capacitor will change, and capacitor is changed, but voltage is fixed, so charge will also change. Charge that will store on the capacitor, that will also change. So if we want to calculate the force between these two plates, that will also be a function of spacing between these two plates. So that's why I'm considering here that the spacing between two plates is x. So at that moment, what will be the force between these two plates? And then it has been asked in the question that when the spacing between them is 2d, so we can put x equals to 2d and we'll get the answer. Okay. So let me write here. So the force between two plates when the spacing is x is F is equals to. So I am using this definition that electrostatic pressure, if any conducting body carrying a local surface charge density sigma, then it's create a electrostatic pressure sigma square by 2 epsilon naught. So sigma square by 2 epsilon naught. But in this case, this sigma will be a function of x. Because the charge on the capacitor will be a function of x, that means sigma, that is charge per unit area, that will also be a function of x. So sigma square divided by 2 epsilon naught, but in this case sigma will be a function of x, that is the electrostatic pressure. Pressure means force per unit area. So that's if we want to calculate the force between these two plates, then we have to multiply the area. So each plate have area A, so this will be the force between two plates when the separations between them is x. Now we can write this sigma in terms of capacitor when the separations between them is x. Let's say when the separations between them is x, that time the charge on the capacitor is q. So I can write this sigma epsilon naught, and we can write this sigma is equals to q, which will be function of x divided by cross section area whole square. Cross section area whole square. And then what will be the charge on the capacitor when the spacing between them is x? This will be simply the capacitor at that moment. So what will be the capacitor? Capacitor at this moment will be A epsilon naught divided by x. And since it is connected with the source, so voltage across the capacitor will always remain V. So into V whole square. So that will be the charge on the capacitor when the spacing between two plates is x. So if we simplify this, what we'll get? We'll get a square will cancel out, epsilon will cancel out. So we'll get A epsilon naught V square divided by 2x square. 2x square. So this will be the force when the plate separation is x. If the plate separation is x and if this capacitor is connected with the battery whose voltage is V, so at that moment when the space separations or the plate separations between these two plates is x, the force will be A epsilon naught V square divided by 2x square. Now in the questions, it has been asked what will be the force between two plates when the x equals to, when the separation is 2D. So that's mean we have to find out force F when x is equals to 2D. So what will be that force? So you can just replace this x by 2D. So when you replace this x by 2D, what will get? A epsilon naught V square divided by 2 into 2D whole square. So this will give you 1 by 8 A epsilon naught V square divided by D square. V square divided by D square. So this will be the force between these two plates when the separations between them is 2D. Okay. So let me check the first option. The force between two plates at a spacing 2D is 1 by 8 A epsilon naught V square divided by 2D. So exactly we are getting same answer here. That means option A is also correct. Option A is correct. Okay, option A is correct. Then take a look on the second option, option B. What has been asked here, the work done in moving the plate is 1 by 8 A epsilon V square by D. So now we have to calculate how much work done is required to increase the separations from D to 2D. How much work done is required to increase the separations between the plate from D to 2D. So how we can calculate this? We already know the force at any moment when the space between the two plates is x. At that time, the force that will acting between these two plates is A epsilon naught V square by 2x. And then if we multiply with dx, that's mean if we want to increase the spacing by another amount dx, so the required work done will be this force into displacement. And then if we integrate from d to 2d, that will give you the required work done. Okay, so right here the required work done to increase the spacing between two plates from D to 2D is W is equals to F into dx, and then we have to integrate D to 2D. Now what is F? So when the plate separations is x, at that moment the force between these two plates will be A epsilon naught V square divided by 2x. So A epsilon naught V square divided by 2x square into dx. And then we have to integrate this D to 2D. So when you integrate this, what we'll get? We'll get A epsilon naught V square. These are constant term, and 2 is also constant, so we have to integrate 1 by x square, and that will give you minus 1 by x, and then just put upper limit and lower limit of the integration. And then if you simplify this, what we'll get? We'll get A epsilon naught V square divided by 2, and finally put this upper limit and lower limit, you'll get 1 by d minus 1 by 2d. So finally this required work done will be a epsilon naught v square divided by 4d, divided by 4d. So this is the required work done to increase the spacing between two plates from d to 2d. So in option B it is written that required work done will be 1 by 8 epsilon naught v square divided by d, but what we are getting here, we are getting a epsilon naught v square divided by 4d. So that means option B is not correct. So option B is not correct. That's mean wrong option. Option B is wrong. And then finally we have to find out one more. So you have to check one more option, that is option C. So in option C it is written the energy transfer to the voltage source is A epsilon naught A v square divided by D. Okay. So how we can calculate this, how much energy will transfer to the source? And before that also, if I ask you questions, usually when we charge the capacitor, the energy is transferred from source to capacitor. But in this case, in the option, it is written how much energy will transfer from to the voltage source. That means energy will transfer from the capacitor to the voltage source. So why this will going to take place? Reverse problem. Like usually the charge flow from source to battery, source to capacitor. But in this case, it has been written that energy will transfer to the voltage source. That means charge will transfer to the capacitor to the voltage source. So that will going to happen here. Why that you can understand from here. You see, when we have calculated this initial charge and we have calculated this final charge, we can see here the charge in the final charge is always less than the initial charge. And capacitor is still connected with the source. So in this case, the amount of charge that will reduce and that amount will charge will actually go to the voltage source, and because of that some amount will transfer to the voltage source. So how much energy will transfer in this case? So the energy transfer to the voltage source, so the energy transferred to the voltage source is how much? So in this case we can write delta U equals to the voltage across the battery, that will always remain same V, and then the amount of charge that will transfer to the capacitor to the voltage source, that is the amount of charge that is reduced on the capacitor, dq. So already we have calculated here how much energy will charge reduce in the capacitor. So this amount of charge will reduce in the capacitor, so we have to put this value there. So this dq is A epsilon naught V divided by 2D, A epsilon naught V divided by 2D. So V into A epsilon naught V divided by 2D, and this will give you half A epsilon naught V square divided by D. Okay, so this amount of energy will transfer to the voltage source from the capacitor. From the capacitor. So if we check option C, in option C it is written that the energy that will be transferred to the voltage source will be half epsilon naught a v square by d, and exactly we are getting same answer here. So that's mean option C is also correct. Option C is also correct. So option C is correct. So that's mean our correct option in this case option A. Option B is wrong, then option C and option D. These three options are correct. So these are the correct option. Option A, option C and option D. Okay. So I hope you understood how to solve this type of problem. So the main idea is when battery is connected with the capacitor, and so after getting the full charge, if we increase the separations between the plate, that time the voltage across the capacitor will always remain constant. You have to remember this thing. But in this case, charge can flow from battery to capacitor to battery, because still this is a closed circuit, so charge can flow in either way. Either charge can flow from battery to capacitor, or it can also flow back from capacitor to battery. So in this case, voltage will remain same. So when you increase the separation, capacitance will decrease, and because of that, the charge that can store on the capacitor, that will decrease, and that amount of charge that is getting reduced for first case from the first case to second case, so that amount of charge actually flow back from the capacitor to battery. And that's why in option C, it has been asked that how much energy will be transferred to the voltage source. Okay, and thank you for watching this video. We'll see you in the next video.